Hey everyone, welcome back. Today on Quantum Science Hub, we are diving into IGCSE Chemistry about stoichiometry, walking through carefully selected past paper questions from the last 5 years to help you practice smarter, not harder. And this is part 1 of the series, so take out your notebook and let's work through this together. Question 1. The ionic half equation for the formation of oxygen during the electrolysis of aluminum oxide is shown. What are the values of X and Y? Okay, so let's rewrite this. Okay, now let's balance the equation first. In here, we have O2, but at the left side, we still have O1, right? So that's why I will put 2 in front. Just because I put 2, now the charge at the left side is affected, which is -4, right? While at the left side, we only have 1 electron. So how many electrons to balance this? Because at the left side is -4, so that's why I will put 4 electrons, and the charge here is also -4. So the X here equals 2 and Y equals 4. So the correct answer is D. Next question. A compound has the formula XF2 and has a relative mass of 70. What is element X? Okay, so we have XF2 equals to 70. So X we don't know, and plus F2 equals to 70. So if you look in the periodic table in here, the mass of fluorine is 19, right? And this is the atomic number or proton number, okay? So X plus 2 times 19, because we have 2 fluorine in here, equals to 70. X plus 2 times 19 is 38, equals to 70. So X equals to 70 minus 38. So X equals to 32. Now, let's find what is the mass of 32 in the periodic table. So the mass of 32 in the periodic table is sulfur, right? We take the bigger number. We are not taking the smaller number, okay? So it is sulfur. So the correct answer here is C. Next question. Aluminum oxide is an ionic compound containing Al3 positive ions and O2 negative ions. Aluminum hydroxide is an ionic compound containing Al3 positive ions and OH negative ions. So in which row are the formula of aluminum oxide and aluminum hydroxide correct? Okay, so Al3 positive with O2 negative. So I will take yours, you will take mine, crisscross, exchange number of valency in here. So Al2, but we put it as the subscript, and O3, right? Next, Al3 positive with OH negative. So I will take yours, you will take mine. So Al1 and OH in bracket 3 times. So Al2, O3 and AlOH 3 times. So the correct answer here is A. Next question. Sodium nitrite contains the nitrite ion and 3 negative. Sodium nitrite is unstable and decomposes into its element. What is the equation for the decomposition of sodium nitrite? Okay, sodium is Na, right? And the ion for sodium is positive because it is in a group 1, while nitrite is N3 negative. So I will take yours, you will take mine, crisscross, Na3, N. Okay? And it says that sodium nitrite is unstable and decomposes into each element. So we decompose into its original element. Na is a metal, right? Sodium is the metal. So we don't put anything in here, just Na. And then plus nitrogen. Remember, nitrogen is a diatomic gas. Okay, so we have to put 2 in here. Now balance the equation. N2, while in here still N1. So that's why I will put 2 in front. But just because I put 2, now the sodium here is also get affected, which is equals to 6. And the sodium here is still 1. So that's why I will put 6 in front. So the correct answer here is 2 Na3N, 6 Na, and plus N2, which is B. Next question. Compound X contains carbon, hydrogen, and oxygen only. By mass, it contains 26.7% carbon and 2.2% hydrogen. What is the empirical formula of X? Okay, so from the question, we know X contained of carbon, hydrogen, and oxygen. So all of them will add up to 100%. So we write in here CHO. Carbon is 26.7%, hydrogen is 2.2, while oxygen, so we have to find the percentage of oxygen first. So how many percent of oxygen? So 100% minus 26.7 and minus 2.2, right? So this is the rest, which is oxygen. So we got 71.1%. Next, we put the percentage of oxygen in here and divide by their own relative atomic mass. Carbon is 12, hydrogen is 1, and oxygen is 16. So the result of this division is 2.225, and this one is 2.2. 71.1 divided by 16 is 4.444. And divide them by the smallest number. So who is the smallest number in here? 2.2, right? So all of them should be divided by 2.2. And finally, you will get 1, 1, 2. So the final result here is C1, H1, and O2. And this is the empirical formula of X. So the correct answer here is D. Next question. The equation for the reaction between barium chloride and dilute sulfuric acid is shown. Which row shows the state symbol for this equation? Okay, so what is the state for barium chloride? If you still remember and watch my previous video about this topic in part 1, you will know if barium chloride is aqueous. Okay, and what is H2SO4? This is sulfuric acid. All acid can dissolve in water, so this is also aqueous. And barium sulfate. Okay, I don't mention this in my previous video. Let's assume if you don't know what is the state for barium sulfate. Next, HCl. What is HCl? HCl is hydrochloric acid, still acid, right? So all acid can dissolve in water. So this is also aqueous. So from here, barium chloride is aqueous, sulfuric acid is aqueous, and hydrochloric acid is aqueous. So from here, you will know if the correct answer is A, because you don't have any other choice instead of choosing A. And this is how you answer multiple choice question correctly, okay? And please remember, for the state of barium sulfate is solid, okay? Next question. A compound of element X has the formula X2O and a relative formula mass of 144. What is the element X? Okay, so we have X2O equals to 144. So X2 in here, so it means 2 times X and then plus oxygen. What is the mass of oxygen? 16, right? So equals to 144. So X2 here equals to 144 minus 16. So X2 equals 128. X2 here means 2 times X, right? So a single X equals to 128 divided by 2. So X is 64. So from the periodic table, you will find out if 64 is copper, okay? So the correct answer here is A. Next question. Caffeine is a stimulant found in coffee. Which formula represents caffeine? Okay, this is a very easy question. What we need to do here is only to count how many atoms for each element, right? So we have carbon. How many carbon? 1, 2, 3, 4, 5, 6, 7, 8, right? So C8. And how many hydrogen? H, 3 plus 3, 6, and then 9, 10, okay? And how many nitrogen? 1, 2, 3, 4. So N4. And how many oxygen? 1, 2, and that's all. So the correct answer here is C8, H10, N4, O2. So the correct answer is C. Question 9. Methane CH4 burns in air to form carbon dioxide and water. what is the balance equation for this reaction? Okay, so methane CH4 and we burn it. Remember, if we want to burn something, oxygen must exist, right? So we have to put O2 in here and it will give you CO2 plus H2O, water. Okay, now let's see the number of carbon here. How many C? 1 C. And here it's also 1 C. And how many hydrogen we have at the left side? We have 4 hydrogen. While at the right side, we still have 2 hydrogen. So that's why I will put 2 in front as the coefficient. But just because I put 2, now the oxygen in H2O also got affected. So oxygen here is 2 and the oxygen in here is also 2. So altogether, they will add up to 4 oxygen. So at the left side, I will put 2. So the oxygen here is also 4, right? So now let's check one more time. Carbon is 1, carbon is 1. Hydrogen 4, 4 hydrogen. Oxygen is 4, and oxygen is also 4. So the correct answer is B. Next question. Which formula is an empirical formula? Okay, so what is the empirical formula again? It is the formula that's showing the simplest ratio between the elements. Now let's check option A, C2H4O. So this is the empirical formula because you cannot divide it by any number again. While option B, you still can divide it by 2, so you will have C2H4O, right? So this is what we call molecular formula, and this is the empirical formula. Next, C3H7COOH. So what is this? So this is actually C4 because C3 plus 1C, right? And how many hydrogen? 7 plus 1. So H8. How many O? O2. So you still can divide by 2. So it will become C2H4O. Okay? This is not the empirical formula but molecular formula. What about option D? This is how many C? 1, 2, 3, 4. So C4, how many H? 3 plus 2, 5, 7, 8. So H8 and how many oxygen? O2. It is the same with option C. So you divide by 2, you will also get C2H4O, right? So this is not the empirical formula, but molecular formula. So the correct answer here is A. Next question. What is the formula of potassium oxide? So to answer this question, you have to know the ion for this compound. Okay, so what is potassium? Potassium is in group 1, so the ion is K positive, while oxide is O2 negative, right? So K positive and O2 negative. So I will take yours, you will take mine. So I will take yours, yours is 2, and you will take mine, mine is 1, so O. Okay? So the correct answer here is D. Next question. Which equations are balanced? Okay, so let's check one by one. Option 1. So we have Fe2 at the left and we have 2Fe at the right. So Fe is balanced. What about oxygen? Oxygen in here is 3 times 2, 6, right? While oxygen at the left side is 3O, so 3 in here and 3 oxygen in here. So altogether is 6. What about carbon? Carbon is 3, and here also carbon 3, right? 3C, 3C. So option 1 is correct. So what about option 2? Zn1, Zn1. What about carbon? 1 carbon and 1 carbon. What about the oxygen? O3, and here is how many O? O2 plus 2O. So altogether, the oxygen is 4. Okay, so this is not balanced because you have 3 oxygen at the left side, but you have 4 oxygen at the right side. So this is wrong. What about option 3? How many NO3 in here? 2 times, right? So there are 2 times NO3, and this is the same because the NO3 in here is times with 2 altogether. What about Mg? Mg1, Mg1. And how about the OH? The OH here is 2 times, right? So we have 2 oxygen and 2 hydrogen. But in here, the hydrogen still 1, while at the right side, you have 2 hydrogen. So this is wrong. What about option 4? Ca1 and you have Ca1. 1 carbon, 1 carbon. What about the oxygen? Oxygen at the left side is 7, right? Because 3 plus 4. What about at the right side? 4 plus 1 plus 2, right? It is also 7. What about the sulfur? So 1s, also 1s. What about hydrogen? Hydrogen is H2 and here is also H2. So they are all balanced. So the correct answer here is B, which is option 1 and 4. Next question. Which row shows the formula of sodium carbonate, zinc nitrate, and ammonium sulfate? Okay, to answer this question, you have to know each ion that contribute to this compound. So sodium, what is the ion of sodium? Sodium is in group 1, so it is Na positive. While carbonate is CO3, 2 negative. So I will take yours, you will take mine, crisscross. This is Na2CO3, right? Zinc nitrate. Zinc is always Zn2 positive. Nitrate is NO3 negative. So I will take yours, you will take mine. Zn1 and NO3. Take this one 2 times, right? Next, ammonium sulfate. Ammonium is NH4 positive. Sulfate is SO4 2 negative. So I will take yours, you will take mine. So NH4, take this number and put it as the subscript. So altogether is 2 times, and SO4, take this as 1 time. Okay, so the answer here is B. Next question. A hydrocarbon contains 85.7% of carbon by mass. What is the empirical formula of the hydrocarbon? Okay, so what is hydrocarbon? It is an organic compound that contains only carbon and hydrogen, right? So carbon contains of 85.7. So how many percent of hydrogen? Then we find the percent hydrogen in here equals to the altogether add up to 100% and then minus with the carbon itself, which is 85.7. So equals to 14.3, right? So hydrogen here is 14.3 and divide by their own relative atomic mass, which you can find in the periodic table. So what is the mass of carbon? 12, right? Hydrogen is 1. So 85.7 divided by 12 equals to 7.142, and any number divided by 1 is the number itself. And altogether divide by the smallest number. So who is the smallest number in here? 7.142, right? So all divide by this number. And you will get 1 in here, and 14.3 divided by 7.142 is 2. So the empirical formula is CH2. So the correct answer here is A. Next question. The formula of a compound containing element X is Na2X2O3. The relative formula mass of the compound is 158. What is the relative atomic mass of X? Okay, to answer this question, then you have to see the periodic table and you will find out if the mass of sodium is 23. Okay, so 2311 Na, and oxygen is 16 8 oxygen. Remember, this is the mass number and this is the atomic number. Okay, we always take the bigger number as the mass. So we have Na2X2O3. And altogether, here the mass of this compound is 158. So how many sodium we have in here? 2 sodium, right? Na2. And 1 sodium, the mass is 23. So 2 times 23 plus 2 times X plus 3 times oxygen. The mass of oxygen is 16, right? So equals to 158. So 46 plus 2 times X is 2X plus 48 equals to 158. So 2X equals to 158 minus 46 minus 48. So 2X equals to 64. then x equals to 64 divided by 2, x equals to 32. So the correct answer here is A. Next question. The equation represents the reaction between solid magnesium oxide and dilute hydrochloric acid to form magnesium chloride and water. So this is the equation. Which row shows the state symbol for hydrochloric acid, magnesium chloride, and water? Okay, so we already know here this is a solid, right? So magnesium oxide here is solid. While acid, HCl, hydrochloric acid, remember, all acid can dissolve in water, so that's why it is aqueous. And MgCl2. Okay, so Mg, we know this is a metal, right? While Cl, chlorine, this is the non-metal. So the type of the reaction between metal and non-metal, this is what we call ionic bond. And we already learned about this in the previous chapter. Okay, so all ionic bond can dissolve in water, and that's why the state here is also aqueous. And water is always liquid, right? So the correct answer here is A. Next question. Aqueous iron 3 sulfate and aqueous sodium hydroxide reacts to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. Okay, let's find out the ions of these compounds. So iron 3, that means it is Fe3 positive, sulfate SO4 2 negative, sodium and A positive hydroxide OH negative. The precipitate of iron 3 hydroxide. So iron 3, it means Fe3 positive and hydroxide OH negative. And a solution of sodium sulfate. So sodium is Na positive, sulfate is SO4 2 negative. So I will take yours, you will take mine. So Fe 2 times, right? You take the number in here and put it as the subscript. And SO4 altogether will take this. So altogether 3 times. Next, NaOH. So it's just NaOH. Now, Fe3OH. So Fe, take this 1 time. But since it is 1, you don't have to put it 1. And OH altogether will have this 3 times. Next, Na positive SO4 2 negative. So I will take yours, you will take mine. So become Na2, we'll take this, and SO4 1 time. Okay, now let's put this all together. So Fe2 in bracket SO4 3 times aqueous. Why? Because it already said in here aqueous and aqueous sodium hydroxide and AOH aqueous. And will produce Fe in bracket OH 3 times. And this is a precipitate. So the precipitates mean something solid, okay? And then plus Na2SO4. And what is the state in here? This is a solution. So it's something that mixed with water. So it is aqueous. Now balance the chemical equation. I have 2 Na in here, but at the left side, the Na is still 1, so that's why I will put 2. Now the Fe at the left side is 2, so I will put 2 at the right side. Now let's check one by one. Fe2, 2Fe. SO4 3 times, but the SO4 here it is still 1 time, right? So that's why I will put the SO4 here is 3 times. Now just because I put 3 in front, now the Na at the right side is 6. But in here, the Na is still 2. So that's why I will change the 2 in here. I will change it into 6. Now check one more time. How many O at the left side? O here is 12 and the O here is 6, right? O here is O3 times 2, 6, while O here is 3 times 4 is 12. So altogether is 18. It is the same at the left side and at the right side. Now, check hydrogen. So hydrogen here is 6, right? 6 hydrogen. And hydrogen here is H3 times 2 is also 6. Fe2, 2Fe. SO4 3 times. SO4 3 times. And A2 times 3, it is 6 and 6 Na in here. So, the coefficient here is 1, 6, 2, 3. So the correct answer here is C. Next question. What is the relative molecular mass MR of sulfur dioxide? Okay, to answer this question, you have to know what is the chemical formula of sulfur dioxide. So sulfur S, dioxide. This is oxygen. And how many oxygen we have? Dioxide. Okay, so there are 2 oxygen in here. So if you check in the periodic table, you will find out a sulfur is 3216. Okay, remember we always take the bigger number, which is the mass number, and the smaller number, this is the atomic number. Okay, so the mass of sulfur is 32 plus oxygen. How many oxygen we have in here? 2 oxygen. And the mass of 1 oxygen is 16, right? So equals to 32 plus 32 equals to 64. Easy peasy lemon squeezy. The answer is D. Next question. Magnetite is an ore of iron which contain the ions Fe2 positive, Fe3 positive, and O2 negative only. What is the formula of magnetite? Okay, so we have Fe2 positive and Fe3 positive. So it will bond with oxygen in here. It will bond with O2 negative, and here it will also bond with O2 negative. So I will take yours, you will take mine. It will become Fe2O2, and we can simplify it into FeO. While in here, I will take yours, you will take mine, crisscross. So Fe2O3. So here comes the tricky part in here. Most of the students, they will answer FeO or Fe2O3. But in this option, we don't have FeO. So they will answer Fe2O3, which is B. But this is wrong. If you answer Fe2O3, so that means magnetite only contain of ion Fe3 positive and O2 negative. But in the question said that it contains of Fe2 positive, Fe3 positive, and also O2 negative. So that's why you have to plus these two, right? So FeO plus Fe2O3 equals to, how many Fe we have in here? Fe3, right? So Fe1 plus Fe2 become Fe3, and O1 plus O3 become O4. So the correct answer here is D. Next question. The structure of glycine is shown. Which row is correct? So it gives us the formula and the number of different elements in glycine. Do you think option D is the formula? No, this is not the formula, right? Because to write the molecular formula, you have to name it one time. In here, you have repeat C, and here is C again, and H2, and you just write H in here again, okay? So we just count how many C in here. 1, 2. So there are 2 C and how many H? 1, 2, 3, 4, 5. So H5, how many O? 1, 2, O2, and how many N? 1 N, okay? So it's between A, B, or C. Now, number of different elements. So how many different elements that we have in here? We have carbon, we have hydrogen, we have oxygen, and we have nitrogen. So there are 4 different elements in glycine. But if the question asking how many number of atoms in glycine, how many atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 atoms, okay? But in here, it is say that number of different elements. So this is all the elements. There are 4 different elements. So the correct answer here is B. Now it's your turn to solve some of these multiple choice past paper questions. You may pause the video to think for a while, and please write your answer in the comment section below. I will check your answer and reply every comment. Question 21. Question 22. Question 23. Question 24. Question 25. Question 26. Question 27. Question 28. Question 29. Question 30. Now let's move to structure question. Question 1. Using the salt form, when aluminum oxide reacts with aqueous sodium hydroxide, is sodium aluminate and AAlO2. Complete the equation for the reaction of aluminum oxide with aqueous sodium hydroxide by inserting the mixing formula and balancing the equation. Okay, so let's take a look in here. Al2O3, right? And then plus an AOH, and it will produce an AAlO2. So we have to split these ions. So we have Al3 positive and O2 negative, while an AOH we have an A positive and OH negative. In here, an A is already taken, right? Aluminum is taken. And O2 here is already taken. So what is left is oxygen and hydrogen, OH. So if you still remember, what will be produced from hydrogen plus oxygen? It will produce H2O, right? Or water. So what is left in here is the product of water. Now balance the equation. So we have one Al at the right and we have Al2 at the left. So that's why I will put 2 in front of this compound. Now just because I put 2, Na here is also get affected with this 2 Na. But in here it is still 1 Na. So that's why I will put 2 as well. Now let's compare one more time. Al2, 2Al, O3, and then plus 2O. So at the left side we have 5 oxygen. And at the right side, how many oxygen we have? 2 times 2, 4, and then plus 1, 5. Right? So 5 oxygen at both left and right side. Now, 2 Na, 2 Na, and then 2 hydrogen and H2 in here. So the balancing equation here is 2, and you put 2 in front, and the side product here is H2O. Next, write the formula of the anion in an AAlO2. Okay, so what we have in here, an AAlO2. If you split on the ion, then we will have an A positive, while the other ion will be AlO2 negative, right? So that's why if they combine all together, I will take yours, you will take mine, crisscross, they will become an AlO2. Go back to this compound, okay? So again, what is anion? Anion, it is negative ion, right? While positive ion, this is what we call cation. So the negative ion in here is AlO2 negative. Next question. Complete and balance the ionic equation for the reaction between Cl2 and I negative ions. State symbol are not required. Okay, how to balance this ionic equation? So it is from atoms want to become ions in here, and from ions want to become atoms in here. Okay, let's start with I2. So I have I2 in here, but at the left side, I still have one I. So how many should I put in here? What is the coefficient? I will put 2 in front of I negative. Next, we have Cl in here. So from atoms want to become ions. Because Cl is at group 7, so the ion will be Cl negative. And how many Cl should I put? In here, it is Cl2, while in here, it is still Cl1, right? So that's why I will put 2. Not just because I put 2, the charge at the right side is negative 2. And from here, it's also a negative 2, right? Because 2 times I negative, and here is 2 times Cl negative. So both already balanced. Okay, let's check it one more time. Cl2, and then 2Cl. 2I, and here I2. 2 negative, and 2 negative. Okay, so that is how you solve this ionic equation. Next, question 3. State the formula of manganese 2 oxide. Okay, so manganese 2 in here, so we have Mn2 positive, right? Because it is 2. And oxide, it is oxygen, so O2 negative. So what is the formula? I will take yours, you will take mine, crisscross, so you will have MN2O2, okay? And then simplify them, so you will get MnO. So this is the formula of manganese 2 oxide. Next, question 4. The structural formula of two compounds A and B are shown. Deduce the empirical formula of A. Okay, let's count for compound A. How many C we have in here? 1, 2, 3, right? So C3 and how many H? 2, 3 plus 3, 6. So we have C3H6. So what is the empirical formula again? So empirical formula, it is the formula showing the simplest ratio between atoms, right? And this is not the simplest ratio because you still can divide them by 3. Then you will have CH2. So the empirical formula of A is CH2. Next, for compound B, we have how many C in here? 1, 2, 3, 4. So C4, how many H? 3, 4, 5 plus 3, 8. And then all of them still can divide it by 4. Then you will get CH2 as well. So the answer here is also CH2. Next, question 5. Balance the symbol equation for this reaction. Okay, if you still remember how the easiest way to balance chemical equation, we always put hydrogen and oxygen, we put this at the last, okay? If you see any hydrogen and oxygen, we just forget about it, just focus on the other element first. Okay, so we have 4 nitrogen in here, but the nitrogen here is we don't know, so that's why I will put 4 in front. But just because I put 4, now the oxygen here is also get affected, right? But we don't care about this first because we also have another hydrogen in here, which is 12 in here. So how many hydrogen should I put at the right side? I have to put 6, right? So 6 times 2 equals to 12. Now, what about the number of oxygen in here? Oxygen here is 4, oxygen here is 6. So altogether, the oxygen is 10. So I will put 5 at the left side because 5 times 2 equals 10, right? Okay, let's check one more time. 4N, 4N. H12 and the H is also 12 in here, right? 6 times 2 equals to 12. What about oxygen? Oxygen here is 10 and oxygen here is 4 plus 6. Okay? So all balance in here. Next, question 6. Oxygen and water react with NO to produce nitric acid as the only product. Write a simple equation for this chemical reaction. Okay, so NO, it reacts with oxygen. Oxygen is a diatomic gas, so you have to put 2. And then water, it is H2O. And to produce nitric acid, what is nitric acid? HNO3. Now, balance this chemical equation. How we balance it? Okay, so let's count from oxygen. Oxygen at the left side is 1 plus 2 plus 1. So oxygen here is 4, but oxygen here is 3. So we find the common multiple, which is 12, right? So I will put 4 in front of HNO3. But just because I put 4 in front of HNO3, now hydrogen and nitrogen also got affected. So hydrogen here is 4 and nitrogen here is also 4. So what is the coefficient I put in front of H2O? Because I want to get 4 hydrogens, and that's why I will put 2 in front of H2O. Okay? And how many oxygen at the right side? The oxygen here is 12. And don't forget to put 4 in front of NO because the nitrogen here is 4. So how many oxygen at the left side? Here you have 4 and here you have 2. So all you need here is 12 oxygen. 4 plus 2 is 6 and you need the other 6 oxygen. So that's why you will put 3 in front of O2. And here the oxygen is 6. So altogether the oxygen is 12. Okay, let's check one more time. 4N. Also here 4N. Hydrogen here is 4 and here 4H. Oxygen altogether here is 12 and oxygen here is 4 times 3 equals to 12. Okay, so the correct coefficient here is 4, 3, 2, 4. Next, question 7. The relative atomic masses of all elements are compared to one atom of an isotope. Identify these isotopes. So what is the isotope again? It is carbon 12, okay? Or you can also write it like carbon 12. Next, question 8. An organic compound has the following composition by mass. Carbon 64.87%, hydrogen 13.51%, oxygen 21.62%. Now calculate the empirical formula of the compound. Okay, so we write all the information in here. Carbon, hydrogen, and oxygen. And just put all the value of the percentage and divide by their relative atomic mass. So if you check in the periodic table, the relative atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. So the division of 64.87 divided by 12 is 5.405. And any number divided by 1 is the number itself. 21.62 divided by 16 is 1.351. And then all of them divide by the smallest value. Who is the smallest value of all of them? 1.351. Okay, so all of them divide by 1.351. So the result here, you will get 4, 10, 1. So that means C4H10O. So the empirical formula is C4H10O. Okay? Next, question 9. Compound B has the displayed formula shown in figure 6.1. Deduce the molecular formula of compound B. Okay, this is quite easy. Just count how many number of each element in here. Okay, so we have carbon. How many carbon? 1, 2, 3, 4, 5. So C5. And how many hydrogen? Hydrogen, we have 1, 2, 3, 4, 5, 6 hydrogen. So H6. And how many oxygen? 1, 2, 3, 4 oxygen. Okay, so the molecular formula here is C5H6O4. Next, question 10. Balance the symbol equation for this reaction. Okay, I think we should start from Fe. Okay, in here we have 4 Fe, while in here we still have 2 Fe. So that's why I will put 2 in front. But just because I put 2, now the oxygen is also get affected. But we just ignore it first because we still have sulfur in here. So how many sulfur at the left side? So we have S2 and then times 4. So the sulfur here is 8. So I will put 8 sulfur in here. Now you can calculate the number of oxygen at the right side. What is the oxygen at the right side? The oxygen here is 2 times 8, which is 16. And the oxygen here is 2 times 3 equals 6. So altogether, the oxygen is 22. Okay? So what is the coefficient that I put in front of oxygen? 11, right? Because 11 times 2 equals to 22. So this is how you solve the balancing equation. Next, calcium burns in oxygen. Write the symbol equation for this reaction. If you want to burn something, oxygen must be exist, right? So calcium plus oxygen is a diatomic gas and it will produce what? So remember, you have to back to the ions again. So calcium is Ca2 positive and oxygen is O2 negative. So I will take yours, you will take mine. So they will become Ca2O2, right? And then we simplify them. The final result is CaO. Now balance the chemical equation. At the left side, the oxygen is 2, but at the right side, the oxygen is still 1. So I will put 2. Now the calcium is get affected. So I will put 2 in front of calcium. Okay? Next, question 12. A student prepares a sample of the insoluble salt barium sulfate. The student adds aqueous sodium sulfate to aqueous barium chloride. Complete the symbol equation for this reaction. Include the state symbol. Okay, so we already know in here barium sulfate is insoluble salt. So the state symbol here is solid. Okay, now just split based on their ions. So barium is Ba2 positive, Cl negative, and A positive, SO4, 2 negative. So they will exchange the ions. So Ba with SO4, right? So they can cancel each other, and that's how you get BaSO4 in here. And finally, we will have Cl, Cl negative with an A positive. So that is what we call NaCl. And what is NaCl? It's just a salt and it can dissolve in water. So that's why we put AQ in here. And now just balance the equation. We have Na2 in here, but in here we still have one Na. So we will put 2 in front. But just because we write 2 in front of NaCl, now the Cl is also get affected, which is 2Cl. And here we have Cl2. Okay, let's check it one more time. Ba1, Ba1, SO4, and we have SO4. And A2 and 2 Na in here. Okay, so everyone is balanced in here. That is how you solve this question. So that's all about some past paper question in this Stoichiometry Part 1 question and answer. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.